Okay, so this story is wild. It's about just one person, a simple ruler, and a whole lot of patience. And it just might be one of the most wonderfully strange and surprisingly profound scientific studies ever conducted.
35. Just let that number sink in for a second. For 35 years, one single researcher meticulously measured the growth of his own fingernails. Day in, day out, year after year.
So what's the deal here? Was this just some weird obsessive hobby that happened to win a novelty award? Or is there a layer of actual scientific genius hidden in this incredibly simple act? Well, the answer tells us something really fundamental about how science actually works. To really get why this matters, we have to first look at what science didn't know. And it turns out there was this huge, really simple blind spot in how we understood our own bodies. So here was the deal. Medical textbooks could tell you, the average daily growth of a nail, but that data was a total mess, a real patchwork of different studies. It's kind of like knowing the average height of a whole forest, but you've never actually watched a single tree grow from a sapling. Nobody had ever just tracked one person for the long haul. And the reason we knew so little was because all the old studies had these major flaws. I mean, they were way too short, subjects would drop in and out, and it was basically impossible to figure out what was causing what. Was it age, your diet, the seasons? The data was just a big, noisy mess of averages. And because of all that noise in the data, some really basic questions, like fundamental questions about how our bodies age, were just completely unanswered. Like, for instance, does nail growth slow down smoothly over your life, or does it happen in big steps? And you know how the nails on your dominant hand grow faster? Does that difference stay the same forever? It's funny, our nails were so common, so right there in front of us, that nobody had ever bothered to do the serious long-term science on them. So how do you solve a problem like this? A problem nobody's touched for decades? Well, you do it with a method that is, and I mean this as the highest possible compliment, boringly brilliant. The whole setup was just almost ridiculously simple. One guy, the same measurement technique every time, the same exact spot on the same nails. The genius here wasn't some fancy high-tech lab. Nope. It was the sheer, unbreakable, monotonous consistency for 35 years. And what he was doing is a perfect example of what scientists call a longitudinal study. See, by keeping everything else the same, the person, the method, the only thing that really changed was time. And that's how he was able to pull a super clear signal out of what used to be just a bunch of noise. All right, so what did all that patience actually get him? What does 3.5 decades of fingernail data even look like when you lay it all out? Oh, for the first time ever, we got some real definitive answers. Yes, nail growth absolutely slows down as you age. But, and this is the cool part, it doesn't happen in a straight line. It happens in stages. And yep, the nails on your dominant hand are always faster. These were patterns you could never see in those old short-term studies. And this is where you see the real power of this whole thing. It wasn't about finding a new average for everybody. It was about showing, with crystal clarity, the unique biological story of aging as it happens inside one single individual. Okay, so this brings us to the biggest knock against the study, which, funnily enough, is also its greatest, most unique strength. So in any basic statistics class, they'll tell you that a sample size of 1, what they call n equals 1, is pretty much useless for making big claims about everyone. And you know what? That's totally true. Even the researcher himself was the first to say it. He'd tell you, hey, this is not a study for generalization. You can't look at his nail growth and say, this is how every single person's nails grow. That was never the goal. Right, because the purpose was completely different. This wasn't a study for making generalizations. It was a study to test if those generalizations even hold up. It was designed to check if the averages we get from bigger studies actually mean anything for a real single person over time. In other words, this 35-year record is a perfect baseline. It's a rock-solid, fixed point of reference you can measure everything else against. Think about it like this. All those big studies with lots of people, they give you the satellite view, right? The whole mountain range. But this study, this is like a single, perfectly placed camera, just recording the slow, subtle erosion on one peak for decades. It doesn't compete with the big picture. It makes the big picture so much sharper. And all of this kind of builds to one final big idea, one that goes way beyond fingernails and gets right to the heart of what scientific discovery is all about.
So on one level, this whole project kind of reframes what a fingernail even is. It's not just dead cells, right? It's a physical, integrated record of your life. It's your health, your stress, your aging process, all recorded there in super slow motion.
But on a much bigger level, it proves something really profound about science itself. Sometimes the most powerful tool you have, the most advanced method, is just not quitting. The continuation itself becomes the methodology. And when you think of it that way, this study isn't so weird at all, is it? I mean, the subject is a bit unusual, sure, but the scientific principle behind it is exactly the same one that gives us priceless century-long climate data or decades of ecological tracking. It's classic science through and through.
So in the end, this incredibly humble study of fingernails makes us ask, what is science really? Is it about brilliant flashes of genius and crazy expensive equipment? Or is the most powerful tool in science just finding a good question and then having the patience and maybe the stubbornness to just not quit?